Okay, hello everyone. My name is Paul Bowden. I'm a Principal Consultant with Nanga Systems. Welcome to today's webinar where I'll be talking about the Reuse Company's Requirement Quality Suite and combining that with two tools from the PTC Integrity family, Integrity Lifecycle Manager and Integrity Modeler. Just a couple of notes on housekeeping. If you want to ask a question, I'll take questions at the end. So if you could please type the questions into the WebEx chat window. Make sure you've got me, Paul Bowden, selected as the recipient. And then at the end, we'll go through any questions that we have time for. And if you have any problems with the WebEx, please chat with the Reuse Company. So you should see the Reuse Company as the host of the webinar. So if you just chat with the Reuse Company, Javier from TRC will help you out with any issues you have. Okay, having said that, I'll make a start. So on today's agenda, I'll just do a quick overview of the company I work for, Nanga Systems. You may not have come across them before, but I'll just give a quick outline of who we are. I'll talk briefly about the motivation for today's webinar, how you might find it useful to link together the technology brought by the Reuse Company and PTC in the form of Lifecycle Manager and Modeler. I'll then dig into a little bit more detail the two product families. So we'll look at the two integrity components we're going to be looking at today. Then I'll explain some aspects of the requirement quality suite, and then we'll go into a demonstration where I'll look at measuring requirement quality, some aspects of authoring, and then how we might use our requirements in our modeling activities. Then, as I say, we'll end that with a question and answer session. So I'll take any questions from the chat box that you put in. Okay, so Nanga Systems, we're a partner of both the Reuse Company and PTC, as well as other companies in the ALM space. So we have areas of expertise in application lifecycle management, system engineering, consulting and implementation, and processes, tools, and methods. We have locations mainly in Germany, our main office in Stuttgart, an office in Munich. We have two offices in the UK, a colleague up in Glasgow, and myself down here in London, UK. And we also have a development branch in Kiev in the Ukraine. Currently we have 23 people on board. We were formed in 2014, and our CEO is Dominic Castle, who's a long history in the ALM space. The services we offer are mainly around the process, systems engineering, and application lifecycle manager, also with expertise in agile, lean, implementation of processes and implementation of tools to support those processes. So in a very few words, that's Nanga. Okay, so why might this topic be of interest to us? I think with the fields we operate in, the cost implications of errors in our requirements are very well known. For instance, a study by NASA showed that if we measure 1 unit of an error, that the cost of repairing an error at the requirement stage might be 1 unit. This very quickly builds up as we go down the life cycle chain to maybe 16 times at manufacturing and up to 1,500 times when it's in operation. So clearly it's in our interest to get our requirements right as early as we can and ensure the quality of our requirements going forward. So those requirements impact a host of other artifacts and disciplines. So they will be feeding into other activities on the V. So they'll be feeding down into the development of specifications across the V into our verification and validation activities. As well, if we're involved in modeling, there will be a key input to our model-based systems engineering, model-based software engineering, and also vitally feeding into the product lifecycle management. So the requirements for our physical systems, so the requirements going into the PLM system. Very important that we get that right, as this is going to affect manufacturing later on. Disconnected process and tool chains can make it difficult to realize the benefits of starting out with quality requirements. So making sure that the requirements are available to everyone in a timely manner, and making sure the impact of those changes to those requirements is understood ahead of the change and then acted on in a timely fashion after the change. So ALM systems can effectively leverage this high quality of requirements by giving us that connectivity across the V. So with an ALM system, we can connect our requirements to our V&V activities. We can connect it more effectively to down the chain through input requirements, to our actual requirements, to our specifications, to derived specifications, etc. So the traceability and connectivity offered by ALM tools gives us a great benefit in realizing the benefits and the effort that we put into crafting higher quality requirements. Another aspect of this is coming back to the model-based systems engineering topic. There is a line to be drawn between our switch from textual requirements to model-based requirements. But this can, as the company matures and as different disciplines mature at different rates, this can be a little bit difficult to manage. So if we're creating and maturing the discipline of our textual-based requirements, this can give us a better feed into our model-based requirements, giving those a better stability, and then allowing us to mature the practice as we move from textual requirements into a more model-based requirement environment. And we want to be able to measure the quality of our requirements in a quantitative way. So we want numbers to come out of this whole process. So for example, we can look to the COSI requirements rules, and they give us a whole set of quantitative measures that we can apply to get figures out of how our requirements are. So here's a quick look at some of the tools, well, the tools that we'll be looking at today in the PTC Integrity family. So we'll see a matrix here of what we call solution accelerators. So process director for authoring processes and disseminating processes within the organization. Asset library for asset reuse. And then within the two columns here around systems engineering, we have model-based systems engineering covered by PTC Integrity Modeler, which gives us system design and product line engineering capabilities. Requirements and validation covered by the Integrity Lifecycle Manager tool, which is giving us requirements management, test management, also aspects of project and portfolio management. So Lifecycle Manager is providing a global unified ALM platform that supports all activities associated with engineering and delivery of application and products. Integrity Modeler is a solution for systems engineering using SysML or other profiles, maybe MODAF, DODAF, UPDM, etc. for our systems engineering. Also providing UML profiles, so we can do our software engineering in Integrity Modeler, as well as unique among the market, variability modeling. So if we are engineering a product line, we can model our variability within our system model, and then use that system model to structure how our requirements might be structured to support a product line, how our V&V activities might be structured to support a product line. One aspect we won't touch too much on today is global software development supported by Integrity Lifecycle Manager. But within there, we can obviously use Integrity Modeler for our UML modeling, software design, Lifecycle Manager for software process and workflow. So we can use Lifecycle Manager for modeling agile processes to manage our software delivery. And then it's also configuration and release management within Lifecycle Manager, so aspect of using it for configuration management, version control of software artifacts. But having said that, today we'll concentrate on Integrity Lifecycle Manager for requirements engineering, requirements management, and Integrity Modeler for model-based systems engineering. So looking at the requirements quality suite. So this is the tool suite offered by the Reuse company, and it's intended to tackle requirements quality management, offering a set of tools and processes. So it offers the automatic measurement of requirements quality metrics. So this is the quantitative measure, so we can get definite numerical measures out of out of the tool, so we can see, we can get definite measures of how our requirements are performing against a set of rules that we've defined. It supports requirements authoring, so there is an authoring assistant, which we'll see later on in the demonstration, which allows us to more effectively author requirements and ensure that those requirements are of good quality as we actually write them. Also offering a pattern-based approach to allow us to define how we should be approaching, say, functional requirements, system parameters, non-functional requirements, etc., to ensure that the consistency and quality of the authoring of requirements. As well as measuring the quality of individual requirements, one very important aspect is what we call the CCC approach. So it's measuring correctness. So is an individual requirement in and of itself correct? Does it follow our best practice? Is it using a set of defined words from an ontology, from a dictionary that we've defined? Are our requirements consistent? So if we're talking about, say, a particular volumetric measure, are we using the same unit? Are we using liters for every measure, or are we mixing up different units? So are all our requirements consistently talking about the same thing across all requirement sets? And completeness. Do we have a complete set of requirements? And this is backed up by a model which is defined within the reuse company's knowledge manager. So three very important measures there of being able to measure individual requirements correctness, and then across a set of requirements, are they consistent and complete? This is supported by three tools. The Requirements Quality Analyzer. So this is a tool we can use to connect to a requirements management system. You see there we've got PTC Integrity, DAWs, Rectify, Visio, etc. We can also connect to Excel. So an external system is used to store and manage the requirements, in our case today, PTC Integrity. Then Requirements Quality Analyzer will connect to that, and using a set of defined metrics, it will assess the quality of those requirements and then report those quality measures within RQA itself, but also push those quality measures back to the requirements management system. We have the requirements authoring tool, called short the RAT. So this is the authoring assistant. So this integrates with the various tools shown here, Integrity, Rectify, DAWs, etc., and gives you access to the authoring assistant within the tool that you're using for your requirements management. So while working in PTC Integrity Lifecycle Manager, I can launch the requirements authoring tool, either edit or create new requirements, and ensure that they are of high quality before I even submit them back to my requirements management tool. And the knowledge manager is used to manage knowledge around requirements. So things like the dictionaries. So we have a consistent set of terms that we're using: glossaries, concept maps, knowledge models, ontologies, and patterns, etc. So we can define within Knowledge Manager the patterns we will use when we're authoring requirements. So say we'll see later a pattern for a system parameter. So we can fill in slots within these parameters, within these patterns, to make sure our requirements follow a specified and defined set of patterns. This is giving the requirements authors additional help as well. So they're confident that they're writing quality requirements right from the start. So moving on, just before the demonstration, I'll just put things in a little bit of context here about what we're going to look at. So first of all, we look at the Requirements Quality Analyzer. That will take requirements from the Requirement Management System, Integrity Lifecycle Manager. It will then produce a set of quality measures. So it will measure the quality of the requirements in terms of a simple traffic light, in terms of numerical measures. And it will also provide feedback on how those requirements might be improved. So if we make a mistake or we fail to comply to a certain standard or pattern, we'll see descriptions of the errors we've made fed back into the requirements management system. We'll then look at Integrity Lifecycle Manager. We'll see how requirements are manifest in Lifecycle Manager some of the benefits of using it as an ALM tool in terms of traceability. Then we'll look at the requirements authoring tool, how we can use the RAC plugin to author and add requirements to Lifecycle Manager. And then we'll take a quick look at Integrity Modeler and see how requirements that we've managed within Lifecycle Manager can be used within our system model, and then how aspects of the model can be fed back to Lifecycle Manager so that it can act as a traceability hub so that we can more effectively examine the impact of potential requirements and then manage the impact of those requirements once they are changed. Okay. So I'll just switch now to my demonstration system. And here I'm looking at the requirements quality analyzer. So we have a set of available requirements management systems. So these are different RMS connections. So we've got one here we're connecting to an Integrity Lifecycle Manager project. We can have within RQA many different project connections. So this may be the heterogeneous mix of Lifecycle Manager, doors, rectify projects that we're managing within RQA. So we can set these connections up, connect to a particular requirements management database, connect to a particular project within that database, and then manage the requirements thereafter. So I've just connected to that database, and RQA will start. So here's the requirements quality analyzer. So we can see 3 tabs along the top, and I'll start with this quality assurance tab. So what we're looking at here is a set of different rules that we have defined in our quality in the requirements quality suite. So you can see we've got different sets of rules, and we can apply these different rule sets to different projects that we're managing, or different sets of requirements, even down to different requirement documents that we're managing within our requirements management system. So we might have different projects which are working at different levels of maturity. So we might have a beginner's configuration, which is what we'll be looking at here. We have an intermediate, advanced. We might even have here we've got the full and cozy guide configuration. So these are configurations of the different rules that we've got set up, and how the metrics will be measured, and how people should abide by them. So looking at our beginner configuration, we can see we've got in our list here a set of metrics. And within our configuration on per document, we can enable different sets of metrics. So here I've got, I think, 12 metrics enabled in our database. And here we've got certain measures. So let's have a look through here. So here's a simple rule. It's just saying about the text length. So we want to check that the length of a requirement should be kept within a certain limit. So we're measuring high quality requirements. See this green bar here if our requirement text is between 3 and 25 words. So we want to avoid people being too verbose or very verbose in our requirements. So here's another rule. We want shall occurrences. So we want to avoid vague language within our requirements. So we'll ensure that there is one shall within our requirements. So avoid people saying things like should or maybe. Make sure everything is very definite. And we've got other rules where we might have ensure that there's a verb within the requirement itself. So in here we can enable or disable different sets of rules. So these can be either taken out of the box, or an important point to note about the tool is that very customizable. So if you have a particular set of requirements, quality rules which you abide by within your organization, you can configure these within RQS and have your users abide by those rules, and then get quantitative measures about how those rules are being followed. So there's a set of correctness measures, there's a set of completeness measures, and consistency measures. I won't go too much into completeness and consistency there. Slightly more advanced topics, and if they are of interest to you, please get in touch with either myself or the reuse company or anyone else at Nanga Systems, and we can arrange for some more information, more detailed information on those aspects. But in this presentation, I just want to cover some fairly simple aspects of the tools and focus on how we can use the ALM aspects and the modeling. Looking here within the project configuration, so I've connected RQA to an Integrity Lifecycle Manager project, and I've got here, it's found a set of different documents. So it has its requirements, it has some input requirements, a model, tests, and then a specification. So I've configured this to look at a particular requirements document and to use the beginner set of requirement definitions. I've also got there a filter, so I'm only looking at requirements which I consider meaningful within my requirements document. So I'm not particularly interested in looking at headings or comments, so I can set up filters within RQA to say these are the items within my requirements management system that I want you to actually focus on and measure. So going here to the quality control tab, we can select our project requirements, and here's our list of requirements, and we can see quality measures against them. But we'll just run a quality assessment against this. So what it's doing now is it's going to the Integrity Lifecycle Manager as the requirements management system. It's retrieving the text, the latest text for the requirements, measuring the quality, feeding those values back to Lifecycle Manager. I'm doing this manually, but you can set up a scheduled task to periodically update, maybe nightly, update your requirements so we can run through sets of requirements documents. Okay, so there we see our third requirement. Well, first of all, we see several are grayed out. So these are the headings within our requirement document. So these are the ones we've told it not to measure. Several have 3-star measures, so they are high quality requirements. Others are 1-star, so we can hover over those. Maybe have a look at that first one. So this is, if you remember, we looked at the should rule. So this is saying that a requirement must have a shall clause within it. It should include shall. So in this requirement, we've been unduly vague, and we said the power consumption should be 5 watts. By our set of correctness rules, we're saying that should read the power consumption of the fan shall be 5 watts. So looking at the metrics, so we can drill into the overall metrics here within RQA, so the number of high, medium, low quality requirements, and we'll see in a second that we can bring this up into these metrics again into Lifecycle Manager as well. So we switch back to the scorecard, and using the scorecard to browse through our set of requirements and get an overall picture of the quality of those. Okay, so I've now switched to Integrity Lifecycle Manager, and what I'm looking at is the source document for our Project Next requirements. So these are the requirements we've just analysed, and what you may notice is we've got the requirements text, we've got a category for the requirements, we've got some headings and some functional requirements. We've got a traffic light measure of the quality of the requirements, and we've also got our RQS quality summary. So here we've got a description of why RQA considers this a low quality requirement. So it's conditional sentences should be avoided. So we're breaking that particular rule. So this should read shall. So looking down here, we've got we can quickly look through our different requirements. We can also use these filters within here to say, right, let's have a look at, let's filter this document for just the low quality requirements. So we can use the requirements management tool to browse through the requirements. We can use this full text search to further refine our search through our requirements. So as we're working with large requirements documents, we can quickly focus on the requirements we need and the ones we want to look at. A moment ago, we looked at the requirements measures within RQA. So here we've got a similar one within Lifecycle Manager. So this is a simple dashboard and chart which reports on a set of requirement documents and V&V activities within a particular project. So we've got here a set of documents where we're looking at within Lifecycle Manager design. We're doing risk analysis, so we've got some hazard documents, input documents, requirements, risks, etc. So we can see that the documents we've got in the system. Again, there's another benefit of an ALM system. We can have all of these activities connected together within our ALM system. So we're looking at, as well as requirements, we're looking at V&V, risk management. And within this chart here, we can see a set of high, medium, low requirements. And clicking on those, we can quickly drill into those low maturity requirements via a query. So this is showing us what that particular segment of the chart is made up from, our set of low quality requirements. So we can focus on those, go in, manage them, improve the quality of those. So just to drill into those ALM concepts a little bit more, we look at our problematic requirements here, and I'll look at the relationships it has downstream. So what other artifacts is the quality of this requirement affecting? So here in the downstream traces view, we can see from our requirements, it impacts a design, a test, and it also impacts a model. This is a view of a model we have in Integrity Modeler that we'll see in a few moments. So this is saying that this requirement about the power consumption of the fan impacts the battery power supply that we have on our unmanned vehicle that we're considering today. So we can use this for impact analysis before we make a change. And we'll also see that we can use it for impact analysis after the change is made by allowing the tool to notify other users responsible for the designs, for the tests, for the models, that requirements which they depend on have actually changed. So what I've done there was there's a quick access button to the RAT, to the requirements altering tool. So I've opened requirements authoring tool to edit our problematic requirements. So we see here the authoring, the text of the requirement. Over here on the right, we have our correctness metrics summary. So you can see here it's violating the conditional mode. So we can, and then we select that rule, and it's highlighted the word which is causing the problem. So here we know that should be shall. So see, that happened in real time. So we modified our requirement, and we've now got green bars around everything. So our requirement is now of sufficient quality. So we're saying that it's a high quality. We're satisfying all of our correctness metrics. So let's save that. Okay, so two things to note there. Our text has been updated. Our requirement quality is now high. Our quality summary is empty, so we have a sufficiently high quality requirement here. And looking down at the bottom of the screen to our downstream traces, you can see that we now have red traces on our design, upon our test, and upon our model. So what this is saying is that these artifacts depend upon this requirement. So we have a trace from this power consumption requirement down to a design, into a model, and into a verification test. So these artifacts need to be reviewed. And by throwing a suspect trace on it, we're alerting the owners of those documents to the fact that they need to be reviewed. So as a V&V engineer, I might go to the test verification, the verification test, revisit that in light of the changed requirements. I might determine no change is required or an actual change is required. But after I've actually addressed the change to the requirements, I can reset my suspect flag, and that then says that I've taken action to review the change in the requirement, and it is now resolved. At a slightly higher level, a project manager may look across all of the requirements, all of the documents, designs, models, etc., associated with the project, and take a metric of the percentage, or say the absolute number of suspect traces within that project. That's a good measure of how much work is outstanding, so how much debt we're building up within our system. So we have requirements which are changing, but we're not addressing them in a timely way. So our suspect count, our suspect percentage should be tailing down as we move through the project. So I'll just show one more thing with respect to authoring. So I'll just try and use the requirement authoring tool again. So what this has done is I've used the automation button to say, I want to add a new requirement after our power consumption one. So you see, as we had before, we've got red bars around things. So saying that an empty requirement doesn't fulfill the minimum length of a requirement. So what I've done there is turned off the writing assistant. So I've got a free text requirement that I'm just inputting. So it fulfills the various rules, so it's not ambiguous, it's not in the conditional mode. We've got green bars around everything, so that's all okay. But if I say it quickly, that's ambiguous. So we've got live update of the requirement. So as I'm crafting new requirements, I'm able to see as I go through the requirement, I can see the quality of that requirement as I'm just working my way through it. So let's just modify that. I'll now use the writing assistant to create a slightly more complex one. So with writing assistant turned on, I can select a particular pattern group. And select say a physical property. So you notice as I'm typing, we have a particular template set up for a physical property, and it's offering me choices I can make from the ontology. So it understands the ontology we have set up in the background. So a thing starting with C that I can offer here is capacity. So I can press Tab, select the capacity. So I want the fuel tank, so I'll take that. Okay, so that's a quality requirement. We're green on everything, but what we can also look at is its consistency metrics. So we've got a requirement here in terms of gallons, but what it's found is other requirements that we have in the document which are in terms of litres. So it's saying here that we've found one inconsistent element, so we've looked across all of the requirements in our requirement document, and we found an inconsistency. We've got other requirements talking about a fuel tank in terms of a volume in litres, but in our requirement here, we've got the fuel tank in terms of gallons. So here we've got to see a very simple example of making sure that we use consistent measures within the context of our requirements document. So it's telling me I really should use the consistent value of litres. I can recompute those. And again, unlike completeness, you have to, these aren't done on the fly. You can imagine recomputing completeness across a requirement document with thousand requirements in. That can take quite a while. So we're consistent with respect to litres, but what we have now here is we've got a property out of range. So elsewhere we've said that our fuel tank should be in the range of 40 to 80 litres. So our 88-litre tank isn't consistent with our another statement saying that the fuel tank should be between 40 and 80. So we can correct that. We compute that metric. And we're green on that now. Okay, so we can save that. And there's our new requirement 2.2, the capacity of the fuel tank shall be 80 litres. So what I'll do now is I'll go back to this demonstration platform here, and I'll look at the model that we're connected to. We saw in Lifecycle Manager that there was requirements connected to a model. So let's just have a look at some aspects of that model. So what we're looking at here is a system model of our UAV, our unmanned vehicle, unmanned vehicle. And we have customer requirements, system requirements in here. And we've got a small section in here, just for the sake of speed, of requirements which I've imported from Lifecycle Manager. So here we can see the compressor power consumed, so I see 15 watts fan bed, but we're missing the requirement that we've just input. So just let's just have a quick look around this model. So to look at our system structure. So in here we've got, see, our structural breakdown. And in the Lifecycle Manager representation, you remember we had a representation of the power supply. So within our model, we've created traceability, which is the power supply is related to that it satisfies a set of requirements. So down here in the satisfies, we've built up traceability within our model, and then at a high level, we've reflected that traceability in the requirements management side in Lifecycle Manager. So we have a high-level set of traceability within Lifecycle Manager, but a much finer-grained set of traceability within Modeler. So within Modeler, we'll have very fine traces, or a lot of traces going from the model elements. Here we're looking at a very high level at just at the system blocks. We'll have much richer traceability going between the different elements of the model. But for the sake of a high-level traceability, we've reflected one aspect of the model, i.e. the block diagrams, the block structure within Lifecycle Manager. So we can see impact changes at high-level requirements on high-level aspects of the model. And again, if this will only be a very brief overview of modeling within Integrity Modeler. If it is of interest to you, please just get in touch and we can arrange more information. So I'll just conclude by re-importing our requirements. So here we've got Integrity Lifecycle Manager, synchronize. So this is a mechanism which allows us to synchronize requirements from our requirements management tool into the model, and also allows us to create configurations of surrogates in the model, aspects of the model that we're interested for traceability, and reflect those in Lifecycle Manager. So the model document that you saw in Lifecycle Manager was created using an export, using a configuration within here. So here we see we've got the requirement mapping. This is the thing we use to map requirements into Modeler, and the surrogate mapping. This is what we use to map the block structure into Lifecycle Manager. So I can just synchronize that. And there's our updated requirements. So we've got our 80 litres specification there. Okay, so I'll just conclude now. So in summary, the quality of our requirements has an impact on many other disciplines. We've seen as an example within the tools, design, specifications, models, and risk management. ALM traceability gives us the opportunity to measure improvements. So we can use ALM traceability before and after our use of our improvement of requirement quality to get measures of how we're performing or how much rework or requirements churn have been undertaken within projects. So we can build up metrics of during the lifetime of this project, this is the amount of rework we had to do based on requirements change. This is the downflow into design changes, into model changes, into V&V changes, etc. So an ALM traceability tool, as well as giving us the visibility of how these things connect to do impact analysis before and after the event, we get the opportunity to measure our improvement in maturity by deriving metrics across this range of different engineering artifacts and seeing how we perform before, during, and after an improvement in our requirements process. So using Lifecycle Manager as an ALM tool with RQS gives us the opportunity to mature our disciplines and gives us a very flexible path to greater maturity. So I mentioned earlier about the line between textual and model-based requirements. So as we mature our textual requirements, we get a stronger foundation to feed that into our modeling disciplines and start deriving high-quality model-based requirements as well as high-quality textual requirements. Okay, so that's nearly the hour, so I'll conclude there. I'll just have a quick check if there's any questions in the chat box. So it's got one relating to an earlier comment. So can the Lifecycle Manager requirements be used in PLM for the physical systems? Answer is yes, we can link requirements in Lifecycle Manager to parts within PTC's Windchill product. So we can trace from Integrity Lifecycle Manager requirements to physical parts. The suspecting idea works as well across those two domains. So we can change requirements in Lifecycle Manager and then see those marked as suspect within the PLM system. Question here about software. So can requirements feed into UML and agile processes? Absolutely. We saw in an earlier slide that Lifecycle Manager can be used to model different software development processes. So we might model agile processes, and there are agile processes available for Lifecycle Manager. High quality requirements can themselves feed into agile, obviously. So we can feed our high quality requirements built up with requirements quality analyzer and requirements authoring tool, feed those into our user stories and use that as the basis for our agile processes. And that absolutely holds true for UML. As our UML requirements feeding into UML, they can feed into more clearly defined use cases, and then thereafter into our software models. Okay, so that's all I'd like to say for today. My contact details are there, so please feel free to get in touch if you want additional information or would like to follow up on anything. So thank you for your attention today, and I'll say goodbye and have a good rest of the day. Goodbye, everyone.